yesterday or remember that they have the P and the C buttons on the calculator. The P was what we used yesterday, permutation. So actually, it's no surprise that we'll use the C this morning for combination then. So let's calculate it, an example. Okay. Oops. Combination. So let's start with a small enough example. We have 4 people and we want to choose 2 of them for a team. So we don't actually care about the order. The team AB is the same as the team BA. So the order is not important here. So here, 4 people, and if you think about it like this, each person can either be on the team or not on the team. So we could have something like, for example, yes, yes, no, no, for example, or you could have yes, no, yes, yes, whatever. You have to, no, that's wrong. I need to, yes, no, whatever. So really, when you think about it, all you're really doing is kind of reordering the list, yes, yes, no, no. This would be the team with AB on it. This would be the team with CD on it. This would be the team with AD on it, and so on. So what you're really doing is, you're not reordering A, B, C, D. It's more like you're reordering yes, yes, no, no for who's on the team.
Why yes, no?
Yes, you're on the team, or no, you're not on the team. This is really the only choices that's happening. So you're either saying A, yes, you're on the team, B, yes, you're on the team, C, no, and D, no. So really, you're reordering yes, yes, no, no. Here's another example. No, no, yes, yes. Yes, no. Yes, no, no, yes, etc. So if you remember from yesterday, the way you reorder 4 things is by 4 factorial. However, you have 2 repeated here, so we have to divide by 2 factorial, and you have 2 repeated at the end as well, so that's divided by 2 factorial as well. And this is just like what we did yesterday. So
we cannot use the 4P2?
No, because that's only when the order of the team would matter, yeah. So 4P2, I think this is where like maybe the team has a first place and a second place, you know. So you care about the order, whereas here you don't. So for example, let's say we had A1, A2, A3, etc., AN, and we want to choose OR. So you would have, for example, yes, yes, yes. How many times would you have this? Well, yeah, dot, 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 dot. It would be OR times, yeah. And then you would have no, no, dot, 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 no. How many would we have here? N minus OR. And then you can rearrange. So just like what we learned yesterday, it will be n factorial over. Now these can be rearranged, so we have to divide by this or factorial divided by also n minus, yeah, thank you, in English would be great, Albert, n minus or factorial. Now I hope that this looks familiar. You've seen that somewhere before with me.
Let's see.
Yeah, this is exactly the same as n C R. So in fact, in my previous question, This here was the same as 4C2. This one here is NCR. So this is where we choose a combination of OR from N. N choose OR. So this gives us a very nice, easy way to calculate combinations. Yeah. 1, 2, 3. How many have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm missing 2. Remo and who else? Marcelo, that was it. Okay, so I should normally have 12. Yeah, so I'll give you an example. So for example, let's say on Wednesday morning, I know I always miss 2 students, as an example. How many different classroom combinations will I have? So in total, we have 12. But I know that there's 2 people always missing, so I'm only ever going to choose, so to speak, 10 from the 12. So the number of possible combinations, the number of classrooms I could be looking at, and I don't care about the order, is 12, choose 10. So we can calculate this on the calculator. And that's actually 66. So if there's always 2 people missing, that means there's 66 different possibilities. Of course, we all know not all possibilities are equally likely. Right, so let's have a look at another example, maybe something with cards. So we have a deck of cards. And I don't know, we're playing blackjack. So in blackjack you need to draw 2 cards. So my question is, how many combinations of cards could you get if you draw 2? And how many cards in a full deck? 52. Yeah. Okay, so try that on your calculator, see what you get. Yeah. That's it. 52, choose 2, 1, 3, 2, 6. Yeah. Cards. Blackjack. So in blackjack you draw 2 cards at the start. Okay, can I go down? Yeah. So this also works pretty well when you want to choose from 2 different groups. So for example, maybe in this class you have 20 male students and 10 female students, and you want to choose here a team, a group of 4 students. So you want to choose 4 students, but the difference is you want 2 male students and 2 female students on your group. So actually you can still use the choose function, but a little bit differently. Here you have 20 boys, but you're only choosing 2. And here we have 10 girls and we're choosing 2.
Is it plus or?
Yeah, what is it? Plus or multiply? It's multiply here. Yeah. So the total choices, yeah?
It's because like boy and girls, and equals boy or girls, will be plus.
Oh. No. But I know why you think this.
It's not
And I don't have any good answer for you. Yeah. It's not a probability, so don't activate that part of your brain. Yeah. These, I cannot think of any example where plus is really used for these problems. It's always multiply. But if it was boy or girl, actually it would just be this: 30 choose 4, because you just group them all together. 20 choose 2 times 10 choose 2, 8,550. Yeah? Okay. Can I go down a little bit? Yeah, let me give you one to try now. Okay, so let's imagine we have a lottery game. So in the bin there are balls numbered from 1, 2, 3, and dot, 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 and we'll go up to 40. We'll say 40. It can be my game. 40. So for this game, what you have to do is pick 6 numbers, and then what happens is they draw 6 numbers. So let's say for my game, let's say you win a small prize if you match 3 numbers. So you pick 6 numbers, and then they draw 6 numbers. If 3 of your numbers are the same, then you win a small prize. You understand? Like, so for example here, if they get a 10, 5, 3, 1, 20, 30, and you picked 1, 2, 3, 4, 5, 6, then you would have 1 the same, no, not 2, 3 is the same, and 5 the same. So for this ticket you would win because you matched 3 of them. So my question is, how many, well, firstly, how many possible draws are there? So how many possible outcomes are there? Well, I think that one's actually easy. Maybe we'll just do that together. What would it be? 40 choose 6. So that's how many possible draws there are of numbers, which is a lot. Okay, now I want you to try the next part for me. Is how many tickets would match 3 numbers? So this is how many tickets, just so you know. So of course your answer must be smaller than this. How many tickets would match 3 numbers? What do we think? A little too difficult? Or? No idea? Okay, maybe we'll have a look at it. So if you think about it like this, you have your 6 numbers. And how many numbers do you want to be winning numbers? You want, like 3 numbers to be winning numbers. And you actually want 3 numbers to be losing numbers. So if you think about it, you want a winning number, losing number, for example, winning number, losing number, winning number, losing number, for example. So this is just like picking boys and girls for a team. Picking winning numbers and losing numbers. So if you think about it like that, if I was to change this problem, if I instead said, okay, you had 30 males and 20 females, and you want to know how many possibilities there are of 3 males and 3 females, then you have no problem doing this. You all understand that it's 30 choose 3 times 20 choose 3. But it's the exact same situation here, except instead of choosing people, you're choosing numbers. So, how many winning numbers do we want to choose? We want to choose 3. And how many winning numbers do we choose from? 6. There's 6 numbers which are called winning numbers. We also want to choose 3 losing numbers. So how many losing numbers must we choose from? 34. 4 points, yeah. So this is how many tickets you have that could match 3 and not match 3. So 6 choose 3 times 34 choose 3. We get this.
Where did these come from, the 34?
Those are how many losing numbers there are. If there's 40 numbers and 6 of them are called winning numbers, then 34 must be called losing numbers. They weren't picked. Yeah. 40 winning, 40 total, 6 win, so 34 are losing numbers. Yeah? Okay.
Why you don't get 6 to 3?
6 choose 3, yeah.
Is 20.
Yeah.
The first number you get the possible, the orders.
The orders, what do you mean?
You get 40 to 6, you divide it by 20. So you get 1919. The possible answers?
This one divided by 20, no. Maybe I shouldn't have done this part at the start. Do your best to forget about that. Here, you think about it like this. You have how many winning numbers? 6. And how many numbers weren't picked? 34. And it's just like 6 boys and 34 girls. You want to choose 3 from here and choose 3 from here. It's the exact same as the kind of boy-girl, picking them from the 2 different groups. I will do now probability though. So what is the probability that you will match 3? Well, how many possible outcomes are there? 3, 8, 3, 8, 3, 8, 0.
119.
And then on the top, 119, 6, 8. Oh, these are the possibilities of matching 3. So not great, not too bad. 0.03118 is your probability of matching 3 numbers. Yeah.
Not fair.
Actually, for lottery games, not bad actually, because usually the probability is much smaller than this. So this is why you shouldn't play the lottery. You've got really bad chances. Okay, the next part I want you to try for me is, let's say my small prize is, I don't know, 20 euros. This is the prize for matching 3. Yeah? My question, I want how much the ticket should cost so the game is fair. So this is expectation now. I want the price of the ticket so that the game is a fair game. And the prize is 20 euros. So if it helps, you should draw a table and just think about it as only 2 possibilities. Either you win or you lose. Okay, let's have a look here at this one. should be nearly finished. So there's two possibilities. Either you win 20 euros minus how much you paid for the ticket, or you just lose how much you paid for the ticket. Your probability here is 0.03118, and your probability here would be 1 minus 0.3118. The expected value would be 20 minus x. Yeah. Oh, thank you. I'm sure I would have noticed when my probabilities were like more than 1 or something. 20 minus x times 0.03118 plus minus x times 1 minus 0.03118, and we want this to equal 0 to make the game fair. So let's calculate that. So that would be 0.6236 minus 0.03118x minus x. Oh, actually I should put them together first. What am I doing? Minus 0.96882x equals 0. So I get 0.6236 minus x equals 0. So you can see here the price. The price should be at least 62, or I suppose we need to round it up, 63. Yeah, 63 cents at least. So if for this game the ticket cost was €1, unfair or fair?
Unfair.
Unfair to who?
To the customer.
To the customer, yeah, that's it. So what's going to happen here, expected money that the business will make, that would be the expected, how much, what's the word in business? Revenue, isn't it? Do you just use or for revenue? Yeah. Minus the cost. Or if you want, that's expected revenue minus expected cost. Expected revenue, well, it's always €1 whenever. This is expected money per customer, I should say. Or per ticket, even better, per ticket. So the cost is always €1, so the expected revenue is always €1. But the expected cost, that's how much you have to pay, that's your cost, that's 63 cents. I should really say profit, not money, but whatever. 0.37 euros. So each customer, each ticket represents 37 cent profit. Yeah?
Not for the customer.
No, for the business. Yeah. So I mean, when you have, a place like Ireland, how many people play the lottery? I don't know, like if 100, well, a lot of actually, 100, I was going to say 100,000, but maybe it's even more, I don't know, a lot of people play it. If we said 250,000 people play this game, that would be a profit of 92,500.
I see already like old people selling
old people here love the lottery.
in the spa.
Yeah, they love their lottery, yeah. Now, of course, I made my lottery very simple because there's different prizes for different matches. And if you match all 6 numbers, then that's the jackpot. But don't worry, that probably won't happen for you. So, not even worth calculating. Okay, anything else here? Okay, I'll give you one more to try. So let's say, for example, you have at home 20 books and you're going to take a long flight. So you want to have some books you might want to read. So we'll say that you choose 3 books for your flight. So my question is, how many combinations of books are there? Well, that one's straightforward. That's just 20, choose 3. Now, my question now, though, is how would this problem need to be changed so that, 20, choose 3. If I wanted to use 20p3, how would I need to change this problem?
Choose the first 3.
Yeah, so to make it 20p3, the person would have to choose not only the 3 books, but they would also have to choose which they're going to read first, second and third. So if they say, I don't know, book A, B and C, or if they say B, A and C, that's considered a different choice. So for 20p3, that's 6840. So you can see there is a pretty big difference when the order is important and when the order is not important. There's a big difference. Yeah. Okay, now let's see. Yeah. Yeah, okay. I don't think these will cause too much trouble. So you have the C button you can use on your calculator. So you should get these finished before the end. Yeah, I think so. You don't know what happened to Marcelo? He didn't WhatsApp you or anything? Is there an assignment due this week?
No.
Oh, okay.
We signed up free now.
Was there a party on last night? No? Okay. Alright, do you all have one? Yeah?
Close it. The club's closing Monday, Tuesday.
No idea. Sorry. Not information I normally know.